All right, so everyone get this. Okay, imagine you're trying to like tile your bathroom floor,
Yeah.
right?
Right.
But you've only got one tile shape,
Hmm.
and like no matter how you arrange it, the pattern never repeats.
Huh.
Sounds kind of impossible, right?
It does.
Well, that's the Einstein tile,
Wow.
and it is causing a huge stir in the science world.
It really is. It's a major discovery in mathematics, for sure.
Yeah.
You know, mathematicians have been searching for, like, decades for a shape that could achieve aperiodic tiling.
Right.
And David Smith finally cracked the code in 2023, and the implications, I think, go way beyond just abstract geometry.
I think so too, and that's what's so cool about this whole thing, right?
Yeah.
It's like this mathematical puzzle is suddenly showing up in the real world
Yeah.
at like the molecular level.
It really is.
It's like nature is playing with the same rule book as mathematicians.
Exactly. Like, to understand how significant this is, let's rewind a bit.
Okay.
You've probably heard of Penrose tilings, right?
Vaguely. Yeah, those are also about non-repeating patterns, right?
Exactly. Back in the 70s, Roger Penrose, he discovered sets of tiles that could create these fascinating non-repeating patterns.
Okay.
And the crazy thing is, those patterns weren't just pretty to look at. They
Right.
led to the development of materials that had unique properties.
Oh, wow. So this whole idea that like disorder can create something useful was already in the air.
It was.
Yeah, I've
Then
heard
in
that.
the 80s, Dan Schechtman,
Oh, yeah.
he discovers quasi-crystals,
Right.
which are basically 3D Penrose tilings.
Okay.
These materials, they have these stunning non-repeating patterns at the atomic level.
I bet people were like, what?
Oh,
When
absolutely.
they heard that.
Imagine telling the entire scientific community that you found a new type of crystal,
Uh-huh.
and everyone's just like, nope, that's impossible.
Yeah.
But Schechtman stuck to his guns
Good for him.
and eventually won a Nobel Prize for his discovery.
Wow. And now these rule-breaking quasi-crystals are in like everyday items.
Yeah, you bet they're used in things like non-stick frying pans.
What?
And super efficient insulation.
Wow, that's so cool.
Who knew that a seemingly chaotic structure could be so practical?
That is really wild. Okay, so
Yeah.
we've gone from tiles to crystals.
Yeah.
Where does chemistry come in?
This is where things get really mind-boggling.
Oh, yeah.
A team in Switzerland recently discovered molecules
Okay.
that self-assemble
Hmm.
into an Einstein-like pattern.
Wow.
It's as if these tiny building blocks are reading from David Smith's mathematical blueprint.
So how do you even picture these molecules? What are we even talking about here?
Imagine a tiny fidget spinner
Okay.
with like a star-shaped hydrocarbon core
Hmm.
and 3 arms that are like spiraling out from it.
Okay, I can see that.
And now picture each arm twisting, and it can go in one of 2 directions.
Yeah.
And that's our building block?
So when these things land on a surface,
Yeah.
they're forming these triangular clusters, but the arrangement is always unique.
Precisely no repeats, just like the Einstein tile.
Wow.
It's like nature is solving a mathematical puzzle right in front of us.
But why would molecules choose to arrange themselves in this way?
That's a great question.
It seems counterintuitive that disorder would be like the preferred state.
That's where the concept of entropy comes in.
Okay.
It's not so much about choosing
Right.
as it is about finding the most energetically favorable arrangement.
Okay.
So imagine these molecules are constantly bumping and jiggling around, you know,
Uh-huh.
trying to find their most comfortable position.
Yeah.
And for these molecules, that happens to be a non-repeating pattern.
So this suggests that a periodic tiling, this seemingly bizarre mathematical concept,
Right.
is actually woven into the fabric of how nature works
It seems that way.
at the molecular level.
Yeah.
That's crazy.
And remember how Penrose tilings led to new materials? Well, these chemical monotiles could be revolutionary.
In what way? Give us some specifics.
Imagine electronics that are far more efficient and compact
Okay.
because the circuits are based on these non-repeating patterns. Or think about optics. We could create materials that manipulate light in completely new ways.
So this could be bigger than quasi-crystals.
Potentially, yeah.
Wow.
And it all stems from a mathematical puzzle
Yeah.
that seemed purely theoretical just a few years ago.
It makes you wonder if we hadn't discovered the Einstein tile mathematically,
Yeah.
would we have even recognized this pattern in these molecules?
It's a great question.
Yeah.
It highlights how interconnected different fields of science really are.
Totally.
You know, we're constantly making connections and building on each other's discoveries. This is just the beginning of the story.
And who knows what other hidden patterns are waiting to be found out there.
Right.
Maybe the key to unlocking new technologies and understanding the universe lies in embracing a bit of disorder.
That's a thought-provoking idea to leave our listeners with.
Definitely.
Thanks for joining us for this deep dive into the fascinating world of the Einstein tile.
Absolutely.